Hello, welcome to Math 1960 Calculus 2. This is part 2 of lecture 3. We're going to solve problems at this part of the lecture. So first we want to find the volume of the solid generated by revolving the region bounded by the graphs f of x equal to x squared plus 2x and the x-axis and the line x equal to 1. So first, this is a graph of parabola. So we want to sketch this graph of the parabola. The first thing we need to do is we want to find the vertex of the parabola. Vertex of the parabola is given by negative 2a and f of negative b 2a. So b here is 2. So 2 divided by negative 2 divided by 2 gives you negative 1. And f of negative 1, we'll plug that in the formula, we get negative 1. So the vertex of the parabola is at negative 1 and negative 1. And so we want to find the x-intercept. To find x-intercept of the parabola, we set this function into 0. So when we set in this function into 0, x is going to be equal to 0, or x is equal to negative 2. So, and y-intercept is equal to 0. So then at this point we can graph the function. The function has vertex here, okay, and it has the x-intercept here. So the x-intercept is 0 and negative 2. So, and it's bounded on this side by 1. This function is bounded by 1. It's bounded between 0 and 1. This is the positive part of this function on the first quadrant. So we're going to revolve it around y-axis. So now we can use the formula, the shell method formula, which says v is equals to 2 pi integral from 0 to 1 x times x squared plus 2x dx, and that is going to be 2 pi, so integral from 0 to 1 of x cubed plus 2x squared dx. That is going to be 2 pi. Do the integration, get x to the fourth plus 2x to the third over 3. So this would be evaluated at 1, 0 and 1, and that should be equals to 11 pi 6 cubic units. So example number 2, we want to find the volume V of the solid generated by the revolving region. This is the region, this is a parabola, and the straight line. So if we graph these, this is a parabola like this. This is a straight line, so both of them intersect at point number 3, at x equal to 3. Then when we plug in, so y is going to be equal to 9. 3, 9. Okay, so this is the region we need to revolve around y-axis. So how did I come up with the 3? Well, I come up, first of all, I equate these two functions together, and then I find the point of intersection of 3 and 4. 4 is negative 4, so negative 4 on this side, and considering the positive side here. So the function, it's going to be bounded, going to be bounded between 1, so here, 1 and from 1 to 3. So when we find the volume, it's going to be 2 pi integration from 1 to 3. So let me actually like pick that. Okay. So to raise that, it's going to be between 1, so and so this is the y-axis here. This is between 1 and 3. So this is the region that we are to consider. So we're going to have x times 12 minus x squared. Uh, this is the x. So b equals to 2 pi integral from 1 to 3 of 12x minus x squared minus x cubed. And then when we take the volume is going to be equal to 2 pi times integration 1 to e of the function we have here, which is 12x squared minus x squared 2x minus x squared minus x cubed x cubed x. So that would be if 2 pi and 2 this is going to be 6x squared minus x cubed minus x to the evaluate from 3. And when we do the evaluation, we should get 116 pi cubic units. In the last problem, we want to find the volume of the solid generated region bounded by the graph. This is going to be an ellipse. So this is an ellipse that looks like this. Here I have A, and here I have 0, and here I have B. Here I have 0 and negative B. Here I have negative A and 0. So this is the region that we are moving around the x-axis. Since we are revolving the x-axis, so B is going to be equal to 2 pi integral from 0 to B y. So g's of y here, we're going to solve this function and express it in terms of y. So that is going to be a b integration b squared minus y squared dy. So, and then now we are going to use the use substitution method. We're going to use the use substitution method. We're going to say uh, um, say uh, u is equals to b squared minus y squared. That means du dy y is equal to 2 minus y. So that means, so if we substitute everything back in terms of u, we're going to have the following. So our integration will be as follows. So b is going to be equal to um, 2 pi times a over b minus negative 1 to integration from b squared to 0 of raised to power 1 half d. And then, so that should give you something like um, I, something I times a b divided by 3 over 2, 3 over 2. This is raised to power, this is evaluated at 0 and b squared. And that should give you at the end 2 I a b squared, b squared. This is cubic units. That's it.